The scattering of light can produce beautiful effects, such as light shafts. They manifest when neighboring light rays are blocked by an occluder, like the citadel walls in this case. Artists often go beyond what is physically correct to create a certain mood or emphasize objects by, for example, sharpening light shafts. Sometimes, light shafts are even added and removed at will or given an irregular look. These days, light shafts are frequently used for games and films, but here the goal is usually physical correctness. For these applications, we propose several techniques to artistically influence light shafts in an efficient and plausible way, giving artists tools to achieve expressiveness in 3D worlds that was previously only available in 2D art. Our contributions are light shaft removal, enhancement and addition using occluder manipulation, light shaft color changes via transfer functions and light map optimization, and light shaft irregularity by controlling heterogeneity. For all of these cases, we explicitly target interactive applications that assume a single scattering model and rely on shadow maps to evaluate visibility. For occluder manipulation, we modify the shadow map. In this scene, we would like to avoid small light shafts. We enable this by filling holes in the shadow map. Using our method, the scene has a more serene look to it. Here, we would like sharper boundaries and a stronger scattering effect. To achieve light shaft enhancement, objects are extruded in a view direction. Our method enhances the light shafts and exaggerates the scattering. Say we want more light shafts to fall through the flower bed. We enable light shaft addition by creating holes in the shadow map using Perlin noise. With our method, we can easily add light shafts in a parameterizable fashion to create a more overwhelming atmosphere. Additionally, we can animate the noise to simulate movement using a time-based offset and resampling. Light shafts can be colored using transfer functions, for which we use a texture that maps pixel parameters to a color. We use the scene depth and the average visibility along the view ray to obtain a color from the transfer function. Say we want more expressiveness in this scene to make the sunrise more dramatic. Using the previously shown transfer function, we obtain a more dramatic appearance. An advantage of the transfer function is that we can use it to recreate the atmosphere in a different scene. We enable users to interactively modify the transfer function using our editor, and keyframing to animate the light shaft colors in an expressive manner. Using light map optimization as an alternative to transfer functions, we can directly draw colors in an image. An optimization process then modifies the light map to best match the drawn strokes. The resulting light shafts correspond nicely to the specified colors. To control light shaft irregularity, we simulate heterogeneity in an efficient but plausible manner using 3D Perlin noise. The heterogeneity can easily be modified by changing the noise parameters. Using a time-based offset and resampling, it can also be animated. For even more control over the heterogeneity, a 3D painting tool can be used. This can be used to modify the scattering intensity or the strength of the heterogeneity. Using our method, we can remove the distracting details while maintaining irregular light shafts. We have presented several techniques to interactively stylize light shafts in an intuitive manner. Our techniques work in real time and support animated scenes. Their ability to reproduce various scenarios that would otherwise require laborious manual tweaking makes them a useful addition to the artistic toolbox.